Assalamualaikum, my dear students. How are you? Hope all of you are well by the grace of Almighty Allah. Welcome to NIEVS Home School. This is Shahjadi Akter, Assistant Teacher of Science of National Ideal English Version School, Beijing. Today I am going to take a physics class for class 9 students. My dear students, our today's topic is Chapter 8 Extra CQ discussion. Our today's lecture number 39 and SW number 34. My dear students, let's start our class. Today we will discuss an extra CQ from chapter 8. My dear students, see this figure here given a concave mirror. This one is a concave mirror M dash. Here also given P, that means pole. This is the F means focal length and C means the center of the curvature. Okay, now see the question. Question number A, what is focal length? Question number B, what do you understand by the value 1.25 linear extension? Number C, in figure, when an object is placed at C, find the position, nature and size of the image. Now question number D, in the mirror M dash, focal length is half of the radius of the curvature. Explain it. My dear students, now we will solve this CQ. Question number A, what is focal length? So, I think all of you have already learned this definition. Focal length means the distance between the pole and the principal focus of the spherical mirror is called the focal length of the mirror. Now, let's see the figure. The distance between the pole and the principal focus of a spherical mirror, that means F. So, this distance is the focal length. I am repeating, the distance between the pole and the principal focus of a spherical mirror is called focal length. That means in figure PF is focal length. Okay. Now question number B, what do you understand by the value 1.25 linear extension? My dear students, this question is very important for your SSC exam also. 1.25 linear extension means the ratio of the length of the image to the length of the object is 1.25. That is, the image is 1.25 times larger than the object. My dear students, this already linear extension means also the magnification also. So, 1.25 linear extension means the ratio of the length of the image to the length of the object is 1.25, and that is the image is 1.25 times larger than the object. So, I think if the question has come whatever this that is 1.25, 1.5, 2.5, 2.25 whatever given, you can write the answer like this. Now question number C, in figure, when an object is placed at C, find the position, nature and size of the image. My dear students, now I am showing this figure only, but you have to write the description of your own, and I think all of you have learned this process. Okay, because we have practiced already 3 or 4 CQ like this. So at first we have to draw a figure. Here given in the question given, when an object is placed at C. So at first draw a concave mirror. Suppose this one is M dash. Okay, this one is concave mirror first. Now draw a principal axis, that here is P. Suppose this one is focal point F. This one is the curvature of the C center, that means C. So in the question given, when an object is placed at C, that means here when an object is placed at C, now we have to find out the image of this position, nature and size. Okay, my dear students, first of all, ray coming to point C, incident on the mirror point P, and after reflection it will go through the sample. Now another ray coming from point, my dear students, suppose this one is the object X, Y. Okay, this one is object X, Y. So now another ray coming from point Y, sorry, this one is X, Suppose this one is y. So another ray coming from point x, and it will be the parallel to the principal axis and incident on the mirror L point, and after reflection it will go through the focal point. Okay. So after reflection it will go through the focal point, and my dear students, you have to draw this line with scale. Okay. Now another ray coming from point x, it will go through the focal point F on the mirror K point, and after reflection it will also parallel to the principal axis. Okay, my dear students, here you have to use this scale to draw this figure. Okay, use this scale. Okay, now these two line intersect at this point. This one is x dash. So draw a perpendicular x dash, and this one is y dash. Okay, so this x dash y dash is the image of object x y, and see, my dear students, here the object this image is the same size of this object. Okay, so you have to write of your own here. This is your SW. You have to write of your own this description and the nature of the image. Okay, so at first you have to write the position. So image is situated at the center of the curvature. Then write the nature. This one is inverted and real. Okay, this image is inverted and real, and the size of this image is the same size of the object. My dear students, I think all of you have understood this question answer, and you can write this answer. Now question number D. In the mirror M dash, focal length is half of the radius of the curvature. Explain it. That means focal length is half of the curvature. That means F, focal length is F, and radius of the curvature R. That means R divided by 2. In the question here given focal length is half of the radius of the curvature. That means F equals to R by 2. So you have to prove this one. Question number D. In question number D, now my dear students, now we will draw a figure also. We have to draw a figure. See, this one is M dash is a concave mirror, and P is pole, F focal length, C curvature, and here given A point. This is coming from light from A and coming from light from ray from point B, and it is incident on this mirror on x point, and if we this ray after reflection, this ray will go through the focal point, and if we extend this line, it will go through the FK point line, and after another way coming from the center of the curvature, and after reflection it will go through the CL line, and if we extend this line, it will go through the XL. So the theta I, this is the incident of angle, and theta R is the reflection angle. Also here theta is incident angle, theta R is reflected angle. So my dear students, please the description. Let a ray BX incident parallel to the principal axis. That means this one BX incident ray parallel to the principal axis, and after reflection it passes through the principal focus, and when extended along XK. Okay, along XK, and another ray directed along center of the curvature passes through same point, and then extended is along XL. Now in triangle CXF, we can write angle BXC is equals to angle CXF, that is theta equals to theta R. So incident angle is equal to the reflected angle, and angle BXC equals to angle XCF. This is on alternate angle. So angle CXF equals to, we can write angle CXF. We can write from here angle CXF equals to angle XCF. So, we can this angle, line is CF equals to Fx, and Fx contains to Fp when Fp is small compared to radius r. So, Cf equals to Fx equals to Fp, and here Fp is the focal length and Cp is the radius of the curvature. That means Fx equals to Cp divided by 2. So, Fx means F focal length and Cp means the curvature, radius of the curvature. So, this is r. So, F equals to r divided by 2 for m dash mirror. Therefore, for m dash mirror, focal length is half of the radius of the curvature, and this is proved. My dear students, I hope all of you have understood question number D, and SW, today's SW number is 34, and C and D do this as your SW. My dear students, I hope all of you have understood our today's topic, this CQ. Practice properly this CQ at home. This is very, very important for exam, and you have to practice more CQ like this for SSC exam also. Okay, see you again in the next class. Allah Hafiz.